Alright, what we're going to talk about in this video is a different idea about differentiated instruction. So most of the time when we talk about differentiated instruction, we're talking about, or at least what I've heard from as a new teacher, is you put the kids into groups or you put them as an individual, and then you can even do partners, or you can do this, or you can do that. And a lot of it has to do with the setup of the class. And I agree that those work, but sometimes we have to look into how we teach the lesson as a teacher. And so maybe we do put them into a group. Maybe we do put them into individual assignments or direct instruction. But the problem is, that I've seen, is that as a teacher, I will sometimes still teach the material the same exact way. And just because they're in a group, if I don't change how I teach it, then they're not really getting anything different out of it. So let's take a concept. If we were to break down our lessons, let's say that we were teaching multiplication and division. And part of that multiplication and division section was the inverse of multiplication and division. Okay? And each piece could be broken down even farther, but I'm just going to stick with the inverse operation. So you have three different kind of categories. You have a complete recall. A recall would be something that you would teach like the multiplication tables. 4 times 3 is 12. 4 times 2 is 8, and so on. That they are being able to digest the material and give it back to you on a given subject. This is one of the lower ends of the students' abilities, but for students who are able to memorize things, they can be able to use that really well in some other parts of their mathematical learning. Being able to memorize things like multiplication tables, I have been able to see students excel because they can add on to that. So rote and recall, really good, and it's something that's really needed. And over time, we'll move into some other things like these right here. So if once again, we're talking about inverse operation. Now, these three different sections here, these are represented by verbal and symbolic representations. So I'm going to start at the top. This would be kind of how I would see myself teaching, and before I was getting into this a little bit more, I would say, all right, 4 times 3 equals 12, and even having these separated, I wouldn't even show division as a representation of, the opposite of multiplication. And so that connection wouldn't really be made. They would see it as two very different things instead of something in the same family of mathematics. So 4 times 3 equals 12, and then 12 divided by 3 equals 4. Making that connection is super important because over time I feel like students who are doing mathematics forget that it's all connected, and they're just learning this piece and this piece and this piece, and connecting them all doesn't happen very often. So another learner could be somebody who's good at English. An English learner, or somebody who's good at English, not an English learner, maybe could be able to read these in a sentence even better. And I've found that some teachers leave some of the word problems alone, or they represent them as something scary instead of another piece that they can use in their abilities for math. It's really hard as a high school teacher to be able to take that idea that word problems are scary and try to work that out of everybody instead of just having it as another piece for them to be able to solve problems. So written and spoken language, these are some of the representations that you can use. So I'll just read off a couple. So what is the product of 4 and 3? So you're asking the same types of question that you would above. And then what do I have to multiply 4 by to get 12? So these are some of the easier representations for sentences, but they're still really useful. And then another way of teaching could be blanks and unknowns for the same material. 4 times 3 is what? And just have a representation of a box. Have a fill in the blanks. Some form of blank that they would have to be able to recall pieces instead of the entire thing. What times 4 would be 12? Now you're going to use this stuff that they have here, and they're using it in fill in the blanks. 12 divided by 3 is what? So this one is really useful when you start working with variables and other things like that, but altogether they really help each other to be able to help different styles of learning. This one is something that I personally hadn't thought about until I had read this paper that I'm referring to in this. This was a visual spatial representation. Now what I saw them work with was that they break this up into pieces. Now you could do this at a desk or in general with blocks, and that will also help, but making a block like this also can do the same thing. So we do have 12. I can take pieces of 3, pieces of 12. I can move them back and forth and ask the kids different styles of questions in that certain block, and being able to, for them to see what they're doing. I found that algebra over time, my short time being able to teach it, is a little challenging because they can't see what they're doing. It's X's and Y's and things that they aren't able to necessarily always see in around them. I've had other students that come back and say geometry is a lot easier because they can see the pieces that they're trying to figure out. But this right here would be able to help them do that. And for those really visual learners, hands-on learners. I hope that this helped some of you be able to kind of break down a lesson. Once again, this was about multiplication and division. That was kind of the overall picture, and breaking down the inverse of some of these and some of the unknowns of the inverse. And I hope that that helps in your desire to teach and being able to learn and become a better teacher.